All right, so I'm doing, you don't have to rewrite that, I'm just doing this so that my notes can see. Chapter 99, I'm doing comparison between alpha, beta, and power. What is alpha? Alpha is the probability of what? All right, so let's start over. I'm drawing this chart. What goes here? And this would be this one. And I shorthand this a lot of times, but since I'm doing it for notes, you reject the what? Or and so I have the same options over here. So what path is this one? What path is this very last one? I have a name for one of the other two. So this one says the null hypothesis was true and I failed to reject it, which means I took somebody to court that was innocent and they turned out innocent, which to me is like the pointless one. This one is what I call the ideal scenario. They did something wrong and I correctly convicted them of it. What's the name for that one? All right, so we found power. Which one is alpha? Because alpha and beta, alpha comes first, type 1 comes first, beta comes second. So alpha is the probability of a type 1 error. Beta is the probability of a type 2 error. Power is the probability that the null hypothesis is false. No, wait, the null hypothesis is false and we correctly reject it. I said something about relationship with one of these. Power equals something related to one of those. Why? It should make sense when you look at this. Because if I know I'm here, if I have a 10% chance that it's a type 2 error, what percent chance do I have that it's power? So that's where that 1 minus beta comes from. So if I want to increase power, this is the part that I'm really making a big deal about today. It's not only those names, but like I could ask you a question on the test that says like if I want to increase this, what would happen? So it's like the direction relationship there, but I'm going to talk through it first. If I want to increase power, what do I have to decrease? Beta with type 2 error. So if I want my correct, what I call the ideal scenario, I have to reduce the probability of a type 2 error. But we know in relationship with our errors, so we always go through and say, let's figure out what our errors are and figure out which one's worse. We figure out which one is worse because if I want one error to be really unlikely, what's going to happen to the other error? It's going to increase. So those work inversely. So the way it works here is these two work inversely, and also these two work inversely, and you've got to think your way through that, which that shouldn't be that hard. The way I just talked through it, if that makes sense, then you can think your way through all this. So if I say, what kind of type 1 error would you want if you want to increase power? Would you want a high type 1 power or would you want a low type 1 power? Type 1 error. So if I want to increase power, if I want a high power, what kind of alpha would I need? A higher alpha. And so that's just that relationship there. So let's write increase alpha means you decrease beta works the same other way. And if I increase alpha, I do what to power? And so that just those two things right there basically says all the different possible options. So alpha and beta work inversely. I guess I should do beta and power. If I increase beta, I do what power? And so sometimes you think, oh, it's going to look better when I write it out this way, and I think it looks more complicated. So if you can understand alpha and beta work inversely, power and beta work inversely, then everything makes sense from there. One thing that I do want to mention, so how do we know if we should, like, since these two work inversely up here, how do I know if I should make it a high alpha or a higher alpha or a higher beta? Depending on which error is worse. So it's context, you think through it, and that's why you have to understand alpha and or what type 1 and type 2 errors are, like in the context of actually doing this in the real world. If one of them is a really, really bad outcome, we want to make sure that that one is low, which means the other one's going to have to be higher, and you've got to do all that stuff before you ever start the study. How can I increase power? This is kind of a weird thing. So I'm going to do a study. And I want to make sure that my ideal scenario is really likely. How can I increase power? Well, based off of what we just set up there, what's one way I can increase power? Increase alpha, which is something that we set initially. There's another thing that's not up here that we can do. I am doing a test. I am going to sample people and collect data. I want to make sure that my numbers are really, really, really good. What should I consider? I'm trying to think about a way to ask this. How big do I want to make my study? So if I sample 5 people, are my results very reliable? If I sample 5,000 instead, are my results a lot more reliable? So how can I increase power? Increase your sample size? There's one other thing that your book mentions, and I don't like this, but I'll explain why they say it. Give me an equation for standard deviation. We've talked about this in the different chapter, but give me an equation for standard deviation. Like in a test. Or last chapter. Like, start there and tell me where to go. And then in proportions instead, and to some extent, whether I use p hat, whatever. Where is n always? So what happens when you increase your sample size? What's it going to do to these? So they mention it as decreasing samples or standard deviation, but that's not really something you do. It's because we're doing a sample. When you increase your sample size, it does decrease your standard deviation, and I just wanted to mention that. I think it's confusing writing decreased standard deviation because it makes it sound like something you can go change. Questions with increased, decreased power? You're going to see a couple of those today. Or maybe